Well, hello physics folks, and welcome to Doc Onco Physics. My name is Keith Onco, and today what we want to do is we want to take a look at vector analysis and just what vectors are and how we analyze them and what we can do with them and why they're important in physics. Vectors are a key component in analyzing a lot of different physics problems because in physics, in math, we can analyze things much more easily when we can break down components into simpler parts, analyze those simple parts, and then put them back together. So you might ask yourself, what exactly is a vector? Well, we have two different types of numbers that we deal with, or things that include numbers that we deal with. One is something called a scalar, right? And a scalar is something that just has a numerical component to it. Like if I said I have 12 cookies, then 12 would be the scalar part of that. It's the magnitude, right? The magnitude of the number, okay? 12, all right? That's the amount, that's how much I have. I have 7 cars. I have 9 marbles, okay? That would be a number, and it's called a scalar number because it only includes the numerical part of what we're talking about. But the reason we need something like vectors is that, let's say you asked me how to get to my house, and I was going to give you directions, and I said, well, walk 200 meters. Well, what's the problem with that? Well, if I'm here, all right, and my house is up here, all right, and actually you're here, right? And I tell you to walk 200 meters, well, you may take off in that direction and you may go 200 meters. Well, did you do exactly what I told you to do? Yeah, right? Did you get any closer to my house? Well, no, you didn't, okay? And so a vector, right, or what would be helpful in the directions that I gave would have been not only if I said go 200 meters, but go 200 meters in a particular direction. So a vector has both a magnitude, all right, that's the number part, and direction, okay? That tells us not only how far to go or how fast to go, but in what direction we should go in. So instead of 200 meters, what if I said walk 200 meters directly east? Well, that makes it a little bit easier, okay? So 200 meters directly east, okay? And then walk 200 meters, so this is 200 meters east, and then walk 200, or say 100 meters north. And you'll be at my house. If you follow those directions, you'll get to my house. You'll get to where your ultimate goal is. Another way that I could give you that direction would be, well, starting from where you are now, walk, say, and I don't have the exact number or the exact distance from this point to my house, but I could also say walk about, and I just did the calculation, so actually I do have it, 223.6 meters, say, I'm just making up this number, 27 degrees north of east, right? So north of east would look something like that, okay? The vector is north, right? North, all right, of an easterly direction. Okay, it's just a terminology that gets used. I could say that. So the vector, a straight line vector, would simply be this vector right here, 223.6 meters, say 27 degrees north of west. And again, that 27 degrees, I just made that number up. It may not exactly be what it would have to be. But it would be giving a direction. It's another way to give the direction of where it is you have to walk. So this would be a little more difficult because you'd have to have a a compass in your hand, I'm sorry, a protractor, with you to tell you where that would be, or you'd have to have a compass or something like that. But you could do it. In physics, we're oftentimes given vectors like this, 223.6 at 27 degrees. But what we need to do is we need to break it up into its component parts, its x component part and its y component part. Okay, and that's what we're going to do in this little session. We want to be able to break up our components. Okay, and what we're going to do, what we're going to need to be able to do that, is we're going to need to be able to use trigonometry. Okay, hopefully you've had some trigonometry in the past. If not, we're going to teach you a little bit about what trig is and how to use it on a very simple calculator in this session. So let's say now I'm going to use my vector here, and I'm going to give it a round number, say 150 meters, and I want to walk 150 meters, and I'm going to do it at an angle of 30 degrees. Okay, and what I need to do is, in order to deal with this in physics, I need to break this up into my x component down here and my y component over here. Okay, now notice that I started out at this point right here and I ended up at this point right here. Okay, so what we need to do here is we need to break up the 150 meters, this vector here at 30 degrees, right? And this is 30 degrees north of east. Okay, we need to break it up into an x component and a y component. Okay, now how are we going to do that? Well, we're going to need to use some functions that we get from trigonometry, some trig functions. Okay, and most of you are probably familiar with trig functions, and those functions are the cosine, the sine, and the tangent. Those are the ones that we will use. We will not be using any of the other functions of trig. So we're really only going to be using the basic stuff. And what does the cosine equal? Well, the cosine of an angle, say angle theta, is equal to the adjacent side over the hypotenuse. Okay, so the cosine, the function cosine of this angle 30 degrees is equal to the adjacent side, all right, of the triangle, all right, divided by the hypotenuse of the triangle. So the adjacent side divided by the hypotenuse. Okay, and by the way, trig functions are primarily work with triangles, so that's what we're working with here. Okay, and we have a 90-degree triangle here. Okay, so that's another basic tenet of trigonometry. All right, the sine of an angle theta, all right, the sine function of the angle theta is equal to the opposite side of the triangle divided by the hypotenuse. So in this case, it would be the opposite side y divided by the hypotenuse value over here. Okay, so the tangent of the angle theta is equal to the opposite side of the angle divided by the adjacent side. So the opposite side in this case would be y, the adjacent side would be x. So depending on which side of the triangle you have information on, you can use one of the three functions here to find out other sides, or two of the three functions to use to find out what the other values of the other sides are. All right, there's an easy way to remember this. All right, it hasn't changed in over 40 or 50 years. And it is this: if you want to remember what they are, all right, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, and you remember SOHCAHTOA. All right, SOHCAHTOA, sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. Okay, so let's say I want to know what the y component of this triangle is going to be. I need to break up the 150 meters into the x and y components. Well, the y component, right, is the same as the opposite side. So which one of these trig functions am I going to use? Well, sine has opposite in it and tangent has opposite in it. But what do I know? Well, I know the hypotenuse. That's 150 meters. So h equals 150 meters. All right, so I have h. So I know h. Okay, I don't know the adjacent side. So it looks like if I use the sine function here, sine of the angle equals opposite over hypotenuse. Okay, so the sine of 30 degrees equals the opposite side, and in our case that's y, over the hypotenuse, which is 150 meters. Okay, if I want to figure out what y is, I just multiply each side by 150 meters, and so 150 meters times the sine of 30 degrees is equal to y. Okay, so that's how we would figure out what y is. How do we figure out what x is? Well, x is that adjacent side. Again, I know the hypotenuse. I want to figure out the adjacent side. So which function am I going to look at? Well, looks like adjacent and hypotenuse have to do with cosine of the angle. All right, so cosine of 30 degrees, and cosine is abbreviated cos and sine is abbreviated sin. Cosine of 30 degrees is equal to, right, the opposite, cosine of 30 degrees is equal to the adjacent divided by the hypotenuse. So the adjacent side, x, divided by 150 meters. All right, if I want to find x, it's just going to be 150 meters times the cosine of 30 degrees. All right, and that's going to equal some value. All right, now, how do we figure out what these sines and cosine things are? Well, if you have a TI-30X or any scientific calculator, they are all going to have the sine and cosine and tangent functions on them. Okay, so if we look at the calculator up above here, all right, and I realize that it's not terribly clear, there's the sine function, there's the cosine function, there's the tangent function. Okay, so if I want to know, all right, for example, what this is here, 150, I'm going to switch to a different color, 150 cosine of 30, so 150 meters times the cosine of 30 degrees. First thing I'm going to do is hit the cosine button on my calculator, and what you're going to get is something like cosine with an open paren. Then I'm going to type in the 30 and then the closed paren, and it's going to give me a value, and I believe that value is going to be 0.866. Okay, I'm then going to take that value of 0.866 and multiply that by 150 meters. Right? So if I take 0.866, 866 times 150 meters, that is 129.9 meters. So my x component here would be 129.9 meters. There's my x component. How do I get my y component? Well, I said that my y component I'm going to get using the sine function, because the sine is opposite over hypotenuse. This is the opposite side right over here. This is opposite of the angle, because my angle is 30 degrees. Here's the opposite side of the triangle, right? And that's the y side. So in order to find y, it's going to be the hypotenuse, right? The hypotenuse times the sine of the angle, sine of 30 degrees, is going to give me the y side. So 150 meters times the sine of 30 degrees will equal the y side. Well, the sine of 30 degrees, when I plug that in, again, I'm going to hit the sine button on my calculator. All right, it's going to give me sine and a parentheses. I'm going to type in 30. All right, close parentheses. The answer to that is going to be 0.5. All right, I'm going to take the 0.5, multiply that times 150, right? Because it's 150 times the sine of 30, and so y will equal 75 meters. And I now have I now have the x and y components broken up. Okay, so let's try another example. Let's say I have a vector here, all right, and I need to turn this again into an x and a y component. This would be y, this would be x. And remember, so ka toa, all right, sine equals opposite over hypotenuse, cosine, I should put the angle in here, cosine of the angle equals adjacent over hypotenuse, and tangent of the angle equals opposite over adjacent. Okay, well, let's say in this case I know that my hypotenuse is going to be 500 meters per second. Okay, so the vector doesn't just have to be distance. A vector can be distance, it can be velocity, it can be a force, it can be a variety of things, which is why it becomes so important in physics that we need to be able to break vectors down. So I would like to know what the x component is going to be. Well, remember the x component, I didn't say what my angle was. Let's say my angle is, let's make that 45 degrees. Okay. Well, my x component, again, is the adjacent side to this angle. Well, adjacent, right, is going to be the cosine, right, as long as I have the hypotenuse, which is what I have. I have the hypotenuse, I'm looking for the adjacent side, and I have the angle. So it's going to be cosine of 45 degrees times 500 meters per second, and that's going to equal the adjacent side of the triangle. So cosine of 45 degrees is 0.707, and if I multiply that times 500 meters per second, I get 353.5 meters per second. Okay, and the way I got the 500 over here was I just took each side and multiplied it by the hypotenuse. Okay, if I want the y side over here, well, the y side is the opposite side. All right, opposite has to do with sine. Okay, so it's going to be, the opposite side is going to be equal to the hypotenuse times the sine of the angle. I'm going to multiply both sides by the hypotenuse. So it's going to be 5 equals 500 meters per second times the sine of 45 degrees. All right, and sine of 45 also happens to be 0.707. And I multiply that times 500, and I'm going to get the same exact thing, which is going to be 353.5 meters per second. Okay, so that's how I break those things up. Let's say that instead of that, let's say I started out with an x component and a y component. Okay, something like that. And let's say my x component is 100 meters and my y component is 200 meters. And I would like to get the value of my resultant vector. All right, so here's my resultant vector here. Remember, the resultant vector is always drawn from the starting point to the end point of any components. So my starting point of my first component was here, right? Here's the end of the first component. Here's the beginning of the second component right here, right there. And the second component ends right up here. I should do that in blue, I guess. Right up there. There's the end of my second component right there. So my resultant is going to go from the beginning, the very beginning, to the very end. So here's my resultant vector right there. How could I get my resultant vector? Well, remember, this is an x component right here. This is a y component right here. So this is 90 degrees right here. We can use the Pythagorean theorem. So r is simply going to equal the square root of 100 squared plus 200 squared. All right, and when we plug that into the calculator, I get 100 squared plus 200 squared equals that. Take the square root of that, and it's 223.6. So r will be 223.6 meters. Okay? And that's how we can get the resultant if we know the components already. Well, what if I want to know what the angle is in here? Can I get that? I most certainly can. All right? Because remember, I can use the trig functions to get, if I know sides and values of sides and things, and I need to know angles, I can use a trig function to do that as well, except there's one little sort of a complication that we have to do, but it's not terribly difficult. So I would like to know this angle here. So remember that, let's use the tangent function. The tangent of theta is equal to, well, if I go over here to the right-hand side, tangent is opposite over adjacent. Okay, so tan theta is opposite. Well, opposite would be 200 divided by adjacent, which is 100. So the tan of theta equals 2 over 1, or 2. Well, I know if I want the angle, or I'm sorry, if I have the angle and I want to know what the opposite side is or the adjacent side is, I can get that. But what happens if I know the adjacent side and the opposite side? Well, there's another function on your calculator called the inverse tan, or inverse sine, or inverse cosine. And what it does is it negates whatever function that you're dealing with. So if I do something like this, tan to the minus 1 of the tan of theta equals tan to the minus 1 of 2, right? And all I've really done is I've applied this operator, tan minus 1, to both sides. Well, tan minus 1 times tan negates the tan, so I'm left with theta equals tan minus 1. It's called the inverse tangent of 2, right? Because it was 2 divided by 1 here, so that's just 2. Well, there's a function on your calculator right above, usually it's right above the tangent function, and to access that, oftentimes you have to use a button called the second button. So I'm going to do that, and if I hit the second button, inverse tangent of 2, the angle I come up with is 63.4 degrees. So theta equals 63.4 degrees. All right? So that's how I could come up with the angle theta in all of this. So that's the basics on vectors. I hope that helps, and we'll see you next time.